Hello and welcome to Sean White's Solar and Energy Storage Podcast. Today we're going to look at something very interesting. It's called a solid-state graphene-based electrostatic storage. Wow, it's a mouthful. And we're going to talk to Stephanie Choi Brookes to talk about it and how this works. Hey, Stephanie, how's it going?
Hey, Sean. Good. Great to be here. Thanks for having me.
Yeah, thanks for coming on. And so you work for Emtel and you make this cool type of energy storage that I guess is not a lithium-ion battery. Maybe you could tell us a little bit about it.
Sure. Yeah. So I'm the Chief Marketing Officer for Mtel Energy USA, which is an offshoot of Mtel Energy based out of the UAE. Together, we are distributors for technology developed by Enercap Technologies in UAE. They've been working on storage for over a decade now and have refined, patented a solid state. You said the whole mouthful. It's solid state, it's electrostatic, it's hybrid graphene, and that means a lot of good things come with it.
Whoa, I know that's a lot of stuff you got going on there too. And then I guess it evolved out of the UAE, so that's the United Arab Emirates. And a lot of people think of that as like Dubai and Abu Dhabi mostly. I've done a bunch of work over in those different places. And have you been over there?
I actually haven't yet. So I was about to go, and there's a little trouble out there right now. So we're waiting on things to quiet down, and then I'll be out there very soon.
Okay, yeah. Then maybe you could go meet they call him like the sheik or the king or one of those guys, you know? I think when I get reincarnated, I want to be some sort of sheik or king.
I see that in your future. I can actually see that in the virtual background there. That's coming for you.
Okay, great. Yeah. Yeah, it'd just be nice to have that kind of power, and you could just make all kinds of decisions, and you don't have to worry about politics and senators and House members and tax cuts. You just make all the decisions yourself. And then over there too, I did some work. One of my trips out there, I've done work for a lot of different companies out there at different times, but one of them was from a company that I guess is sort of like supported by the leadership over there, and it's called Masdar. Have you ever heard of Masdar?
I haven't.
And they have a renewable energy city. They had driverless vehicles before anybody did. I think, they're probably like 15 years ago, they had driverless vehicles. And so they still have them. And it was like a super green campus. And then they developed solar projects. So I was working with the people that were developing solar projects. And I went and saw like a big one in Dubai that was over a gigawatt of PV, which is a huge amount of PV. Plus they developed projects in different countries all over the world and stuff like that. So that was kind of cool to help compensate for some of those fossil fuels that they keep working with over there. We got to talk them out of it. Maybe you could do that.
That's true. Yeah, well, and you touched on something important is their innovation, and they're, over there, they're very forward thinking. And this group came up with this technology, did a lot of R&D. They have several patents on it. However, the graphene is not patented because that is kind of where all the magic happens. So the patents are around basically maintaining the benefits of supercaps, but removing the downsides. So they've created the ability to store energy for long periods of time without much loss, even without continuous voltage curve flattening, all the things that typically trouble supercaps, as an energy storage resource. However, we still are able to deliver power in nanoseconds. So it's great for UPS type applications. So we can do power over nanoseconds or longer than a day, 24 hours and longer.
Wow. A nanosecond is so short, I don't even recognize them. And so maybe what we can do too is talk a little bit about some of these things. Like you said, super caps, so like super capacitors. I remember one time, I think it was like 10 years ago, maybe even longer, I was in Shanghai and I was on a super capacitor bus, which was pretty cool. And so I got on it just because I saw it was like a super capacitor bus. And then every few bus stops, it would go up and it would just like take some energy. And one of the things about capacitors and supercapacitors and things like that is you can just put all the electrons in there. And so one way I like to look at it is just like starting from the basics from a capacitor. It's sort of like you have two plates, and one of them you can put all the electrons, and the other one you don't put any electrons. And like repels like, so the electrons like to push against each other. They create electrical pressure that we know is voltage. And then when they're all on one plate, then you can draw a current through there while you equalize those electrons to the other plate. And how is what you're doing different? I know like it's sort of like a capacitor, I guess, right? Or is it, do you consider it a capacitor?
It's I get a little picky about these things. We don't like to call ourselves capacitors because people do relate to those limitations, but it is supercapacitor based. So it is functionally very much built off of what you're describing. But as I mentioned, the patents are around being able to remove the downsides of supercaps and make them short to long duration and fit multitude of use cases that supercaps have thus far really not been able to function in well. And then the combination of that with graphene creates this synergistic marriage because, as we know, graphene is really popular right now. It's like an energy buzzword, and its surface level allows a lot of density. You can pack them in. And because we're solid state, there's no movement. We can really have a density that no one else is seeing right now. In fact, the manufacturer is releasing a new density at 800 watt hours per kilogram. So it's pretty mind blowing, actually.
Wow, wow. Yeah, I've heard in the past that they would just say that the holy grail of energy storage is to get, like you could call it energy density or maybe more like specific energy. And you could hold a whole bunch of energy in with a smaller weight, that's specific energy, or smaller volume, energy density. And so it sounds like you're making progress there. And another thing too that you mentioned was long duration energy storage. And a lot of people just say LDES, long duration energy storage. And you don't really hear of anybody talking about long duration energy storage in the same breath as a capacitor or a supercapacitor. And I think because usually they're used for really super short-term energy storage, because in order to hold a bunch of energy, with your specific energy or your energy density, you just wouldn't have that with the capacitor or the supercapacitor. So it sounds like something brand new to me that I haven't heard of. How would you compare the energy density or specific energy to lithium-ion batteries?
Right now, we're at the 800 watt hours per kilogram. It's pretty much double what most lithium systems are doing, what most common lithium systems are doing. So we just made a large jump from 460 watt hours per kilogram to 800, which is,
wow,
I don't
that's
expect
quite a
that
jump.
there's going to be a lot more of that. That might be kind of approaching threshold, but we were more even with lithium at that 460. But that's kind of really where otherwise the comparisons stop, because we don't have any thermal runaway because we're not electrochemical, we're solid state. So there's no heat production whatsoever, which means we don't have to be cooled. So we're at 99.1% DC to DC round trip efficiency with most systems. And then, of course, a little bit less than that when you convert to AC. But that's at negative 22 to 140 degrees Fahrenheit. We've been testing systems with the DoD and other organizations for even more extreme temperatures, like negative 60. But in that temperature range, we're at full efficiency. So, lithium doesn't get close to that efficiency on day one. And then, of course, there's steep degradation. And so you have to augment and all of that. We have 100% depth of discharge. So full nameplate capacity. If you're comparing kilowatt hour to kilowatt hour, you just buy what you need with us. Mm-hmm. With lithium, of course, you have to oversize.
Because you can't cycle it all the way down. And a lot of times don't cycle it all the way up. Like I keep my car between 80 and 20.
That's right.
And so as soon as you retrofit my car with some of your Emtel energy super caps, then I'm going to just be able to go 1,000 miles or something?
Yeah, so there is actually a EV module. We call it modules and energy storage just instead of batteries, or,
sure.
You asked about the terminology. I think that's the kind of most direct way to refer to it. And there is a module that they're working on for EVs that will just go right underneath, and it's going to charge in 6 minutes and do twice the range of normal batteries. And of course, that's without any thermal runaway risk, no explosive, there's no hazardous materials. There's nothing that could be harmful. If it did catch on fire, it won't cause an explosion. So without that degradation, there's almost no degradation. So at end of life, which really is 30 plus years because it's that supercap resiliency.
Yeah, I wonder what even would wear out.
Yeah, we say, the warranty is around 95% or greater efficiency at end of life, which is almost no degradation.
Wow, that's pretty amazing. And so what we have right now is what we're talking about is carbon. And so my favorite element really is silicon, because silicon is what you make solar cells with. But carbon, it's kind of important. It's part of our DNA, so it makes me and you. And carbon is what makes organic chemistry, so things that grow. And by the way, we're all related. I'm related to corn, if you didn't know, it's just a lot of generations back. And then besides all of this organic stuff that we have with carbon, we have graphite. And graphite is in the anodes of the lithium-ion batteries, so that's pretty cool. And then I bet Stephanie likes diamonds. Do you like diamonds, Stephanie?
I do.
They twinkle, and they're like a pretty good use of carbon. And there's all kinds of diamonds. There's, the really good ones that are like the Hope diamond and all that kind of stuff. And they make industrial diamonds that they'll put in wires to cut solar cells. They make the wafers. So they get like an ingot, a boule, something like that. And then they slice those things up, and they make you your silicon chips, your solar salami right there. It's kind of how you cut it. But then what you're talking about is a different way of arranging a group of carbon atoms that it doesn't happen in nature, because it is one layer thick of carbon atoms. So it's almost like two-dimensional, which is kind of strange. And I know it's kind of hard to make, but they're getting better and better at making graphene. And some people say that it's, it's got different properties electrically and structurally too. It's super strong. Like maybe someday they'll build a space elevator out of it, so you could just take an elevator to orbit. We'll do something like that. So that's, I guess, what graphene is all about. Where do you get your graphene, Stephanie?
Well, it's funny because you mentioned diamonds, and of course, yes, I love diamonds, but they're also controversial, right? There's mining for diamonds, and so a lot of people are turning to synthetic lab-created diamonds, which are beautiful. You can't tell the difference. Mining, of course, for energy storage elements, lithium, sometimes graphene, can be controversial. That high on their importance scale or low on their importance scale, it should be important in considering what solutions to go with. And so fortunately for us, this graphene that we're using is synthetically created out of waste material. So it's clean from the beginning. There are the majority
of waste material?
Yes. And people are familiar with that. I mean, there's a lot of graphene being used from, I've heard of it in other use cases as well, but ours is specifically, yes, created out of waste material, and we don't have to really purchase it because of that, which helps keep our prices down.
Yeah, look, they'll pay you to take it.
Yes. And graphene can be cost prohibitive. So that's one great benefit with our technology. And then it's also clean through the entire life cycle. So, like I mentioned, no hazardous materials, there's no thermal runaway, no risk of explosion from an external fire source, and it burns like paper. And then we have videos where people they set it on fire on purpose, and you could just blow it right out. And then it's 100% recyclable, 80% biodegradable. So there's no end of life disposal issues, which people aren't talking about enough with lithium, in my opinion.
So have you handled a piece of graphene?
I haven't handled an actual raw piece of graphene. No, I haven't.
I wonder what it looks like, or is it transparent at all, or I don't even know.
Yeah, there was a group that dissected one of our cells. They weren't supposed to do this, and they dissected it, and they were like, yes, we have confirmed that this is graphene.
Wow.
But I'm not sure exactly what else they found. But yes, it truly is. And so it's honestly, you mentioned Holy Grail earlier, and I hate to sound like, I'm a CMO, and so people expect marketing lingo from me, but really it is the Holy Grail. People say it sounds too good to be true. It's a silver bullet. It is all of those things, and it's very exciting, and that's why I'm here.
Wow, that's pretty cool. So what does the graphene do that makes it so great in this application?
Well, part of it is that graphene doesn't have any resistance, so it's extremely conductive. So that allows it to be perfect for energy transfer. And then you combine that, of course, with the supercap based technology that we talked about, not a supercap, but the basis of that technology and those patent benefits. And it really, that's what creates this perfect marriage. And so, and then also the density, because it has such a broad surface area, you can pack those electrons in and achieve really high density.
Wow. I mean, that's just kind of crazy. So, is there any drawbacks? I mean, it seems like, maybe you can't build it fast enough, or you need to build a whole bunch of factories. Maybe it costs a lot. It just seems like it would totally disrupt other types of energy storage.
Yes. And so those are the same questions I asked Philip Martin, who's our CEO, when I talked to him first about a little over a year ago. I said, why isn't this everywhere? Who's the competition? And there really isn't any competition. I mean, there are people trying to come up with something like this, especially with graphene, but they are not as pure as this, or they're too expensive. I did a comparison the other day, a side by side with another type of system, and the amount of space, like we could have, I believe it was like 230 kilowatt hours of this other solution to like 1,000 in some of our solution in the same amount of space. So, I mean, that's kind of the way it compares, even in some of those other aspects. And then our round trip efficiency is 99%. There's 70 at best. And so you look at these things, and there is no real obvious downside. I think the biggest challenges for us have been, we're getting known in the market. And so we have a very large pipeline. We're in the process of completing UL certification. So that's, of course, something that is really important here in the US. So those are the kinds of things that we started Mtel Energy USA to take on for this market. And had we had that sooner, you would have seen this certainly much more places. But we have a large pipeline just waiting for the UL certification to get going. We do have projects already starting. We have a 1.5 megawatt hour system going into Ukiah, California, to take them off grid for 5 days of backup power.
Wow.
And so it's the Geedeville tribe, and there's a pretty small tribe, and they wanted that much backup power, which is exciting. So, and we have pilots coming up with some big utilities with Duke, with Dominion, with Con Edison in New York, some stuff with EPRI. So things are starting to kind of come out that people haven't heard about, but we didn't spend any money on marketing. So I actually don't do a lot of marketing. I've been doing more of the BD and just answering inquiries, but we really haven't done any forward-facing outreach. Mm-hmm. And so it's just been a kind of a process of building on the back end while we bring this technology out into the market and answer the demand.
So are they building these in the US?
So the primary manufacturing is happening in the UAE still, and we have started under Mtel USA manufacturing the M-Wall, which is our residential CNI, like wall-mounted energy storage product. So that will rival, the Powerwall, the Enphase, Franklin, those sorts. And so that's our first product under the Mtel brand. And then we are bringing the containerized systems and the larger use systems to do US manufacturing by the end of the year, and larger production going into 2026.
Great. I would think that the huge application too would be electric vehicles.
Yeah, that will definitely change the way that the EV world works, because I see that becoming a situation where you don't need to charge at home. We pretty much do level 3 and 4 charging. So one of the first projects that was launched out in the Middle East was at Neom, the off-grid city in the middle of the desert. And this solution is perfect for that environment because it's super hot there, and there's no grid connection, of course. And so we have containers doing level 3 and 4 EV charging in the middle of the desert, no grid connection, without cooling. I mean, the AC containers do have a little bit of cooling for the electrical components for the inverters and all, but our DC containers don't need any cooling.
Wow. I guess one way to look at that too is like, if you have really, really good efficiency, then there's no energy left over to make heat. So you don't need cooling for that.
Well, that's true. It's really more the process, right? It's the electrostatic process that makes us lack that heat production. Because of that, we don't have the degradation that you get with cycling. We can cycle, all the way down, like you said. So you can go from 100 to 0 and then straight back up. And so it's really a mind-blowing combination.
Hey, why can't I go to 200% then?
Yeah. So anyway, I think the EV, when I look forward to what will happen with EVs, I think what we'll see is that you won't have to charge your EVs at your home. You can just go to a gas station, and instead of buying gas, you'll charge for 5 minutes and then you can go 1,000 miles.
I think I'd still like to charge at home just so I don't have to go to any kind of gas station. I mean, just doing stuff at home would be cool.
Well, that's true. You can. So
Yeah.
you could certainly do that if you wanted to do like a slower, charge, like a level 2, and you still wanted to do that at home. Sure. But also it makes EVs, I mean, we think about the challenges to adoption. It's range anxiety, which this solves. And then it's, cost in some cases. It's not, readily available. It's access. And then also the depreciation, the degradation of the batteries, as well as the risk, right? And so those are things that people are maybe realizing more now than, 10 years ago. And they might not be comfortable with that. And so with our solution, of course, you don't have that degradation. So your car won't be losing value rapidly in the way that we see right now. And then you also, you don't have to worry about the fire risk, which is huge. And we're also not going to be manufactured by, the company that people don't want to talk about right now.
Okay, we won't bring it up.
Yeah.
Darn billionaires and all that. So how long until you're a billionaire? If you're working at this company.
I don't know the answer to that, but I think that might be, you're going to be a sheik and I'm going to be a billionaire.
Okay. Yeah.
Those are both going to happen.
We'll do some deals together.
Yes, absolutely.
Great. Yeah, so it just seems too good to be true. So convince me that this is real, that I'm not just dreaming.
Somebody told me the other day that they've been waiting years and years. They're a super smart engineer in manufacturing for 100 years. It's a family business. And he told me, he said, the reason I know this is real. He said, I've been looking at graphene for 10 years. I haven't seen anything like this. But the reason I know it's real is because it costs so much to make batteries. It takes a ton of R&D money. I mean, that he's like, it could cost you $100 million just to begin producing the first set. And he's like, you have a 42 gigawatt hour annual production facility, or between our facilities in Abu Dhabi and Dubai, 42 gigawatt hour production. This has to be real. It's been around for a while now. And even if people are just starting to find out about it, that kind of setup doesn't exist in solutions that are not real. We're seeing a lot of companies go under. There's a lot of lithium replacement companies, alternatives, unfortunately, and then also lithium companies going under. We're actually looking at trying to acquire a facility in the US for a company, one of such companies who found that fate. But a lot of them started with production in the US. They built a big staff. And, they took on a lot of overhead expense. They got a bunch of outside investment. We didn't take that approach. So we benefit from having this technology developed outside here by these brilliant people in the UAE. And then, they trusted us because of relationships to bring this to the US. And so now we get this opportunity to market it and bring it, here in a bigger way. And so we didn't take that same approach. We didn't start big scale manufacturing here yet. It's already available. It's already proven. We just submitted 3,000 hours of data to one of the biggest known insurance companies here. And they're almost done with their, review of that to give us bankability and insurance on the product. So that kind of data is not available to new solutions, right? That kind of backing is just not there. And we have that because this is a proven technology. And now we're starting to scale up and take on the larger manufacturing and to grow our staff and our team. So it's a smart approach, in my opinion. And it is based on proven technology. It's not a concept.
So if this is true, and it turns out to be true, you would disrupt energy storage. Your company would be a big threat to big lithium. Are you worried that there might be some lithium gang members that are out to get you?
I do think that we will make some people unhappy. I do know that. But, one of the things that I love about it is that most everybody wins, right? Solar wins, and solar needs a win right now. We integrate, like our containerized system, the Impact, it integrates up to 8 energy inputs. Someone asked yesterday, why would you even need 8 inputs? I don't know. Most people would not have 8 inputs, but it can take the energy server, which is the other patented product. It can take and blend power and prioritize power based on needs for 8 inputs. So that can be, optimizing generator usage, hydrogen, wind, of course, solar, any of those, nuclear. You can take any of those, and grid, of course, grid following, grid forming capability, and then have the perfect solution for whatever your day looks like, wherever you are in the world. And so I consider that a win. We're looking at things from taking, tribes in northern Canada who have no cold storage reliability and no ability to have a fresh food because they don't have reliable power. They're on a generator, and they could go off grid with our M-Wall. Our M-Wall is meant to take people off grid because it can have full depth of discharge, because it's long duration. It's not a backup the way those other systems are created. And I don't think people realize that at first. They think that they could go off grid and they get excited. They have solar and they have a power wall. And unfortunately, that doesn't take you off grid for one day, maybe, but not beyond that. And so this actually can take people off the grid and give them, independence, power sovereignty, and energy sovereignty. And so there's that kind of use case all the way through data centers who are, taking in tons of power and disrupting grids because there's just not enough production from the grid. We will work with those. We're working with those utilities to provide power that they are simply unable to produce right now, so that we can all continue using the AI tools that we've come to love. So it's that huge spectrum. It's everybody from affordable housing, where we can bring people off grid right away so that they don't have to see a utility bill on power, and nursing homes who have life support systems that they need running. And nobody wants to use loud and, dirty diesel generators all the time. So it makes me really excited.
So I was also wondering, like, say this technology really takes off, and I mean, it holds twice as much energy as lithium-ion batteries. So would you license out your technology to these other companies so that the whole world could scale up? Or I know that's probably not your decision to make, but maybe that would be a good idea.
Yeah, it could be. We'll see what happens. I mean, there's endless possibilities really for how this could play out, but I don't think that we'll be sitting here distributing for a terribly long period of time before something bigger comes down the line.
Cool. And then just out of curiosity too, the M-Wall, so that's EMWALL from Emtel, EMTEL, Energy USA. How many kilowatt hours is that?
So we use modules that are 8 kilowatt hour increments. So each one is 8 kilowatt hours and then can be sequenced. So we're actually relaunching that product with a new enclosure, and you could start at 8 and then you can do up to 16. So 2 modules in one enclosure. And that's enough with some solar, or even people who have a generator already, to cover your nighttime usage. So if you had solar during the day, you could use the energy storage at night, and you pretty much get yourself through a 24-hour period. And then you can put multiple enclosures and multiple cabinets in parallel. So if you had 2, that's pretty much taking you off grid for most homeowners. And so, and then you can go up from there to have more backup. And so you can really choose, do you want to use it every day and offset your power usage, or take yourself off grid? Do you want to reserve some in case there's an outage, so you could have, an extra 32 kilowatt hours for a bad day? And that's really a huge difference with the existing solutions, because as you mentioned with your EV, you don't want to cycle it fully, right? You shouldn't, it won't start from zero. And so with that, you have to reserve your cycles. It also degrades so quickly. So if you look at a warranty on a Powerwall, it says end of life, 10 years, they warranty it at 70%. And that's if you follow all their stipulations, where it resides, whether it's connected to the internet, all of these other factors. You can only cycle it once a day. all of our systems you can cycle 4 times a day within the warranty. So if you are selling back power, you could sell power back once a day. You could use it the other cycle. So it's extremely flexible. And because we don't have those cycle limitations without degradation, you meant to use the system, which is the beauty of it.
Yeah, and so I was just thinking too, if it's 8 kilowatt hours is one module for the M wall, that's probably about the equivalent of 10 kilowatt hours of a lithium iron phosphate battery that you can't
Correct.
cycle all the way down without, degrading its health and things like that. Mm-hmm. And with lithium ion batteries too, they're very sensitive to the temperature. So if they have to have like heating systems and cooling systems to make them work well. And so with capacitors, I don't think that's much of a problem. So it's probably not much of a problem with your technology. And even if it was really hot or really cold, it should still work. You're just piling up a bunch of electrons. Is that how it works?
That is correct. So I'll just make an analogy. I have 2 little kids. So lithium is like, this bad behaving child, right? It could just fly off the rails at any moment.
Which one of your kids is this?
I'm not saying. I'm not saying. It can throw into a screaming fit and just completely explode, right? At any moment. And if the circumstances are not perfect, anything bad can happen, right? And it could be catastrophic. And hopefully you're not near another, liability, right? There's something else you could have multiple explosions like that, in public, for example. But our system is like the angel child. You can do pretty much anything. You could keep them out all day. You could go on a shopping trip. You could be on work phone calls and working around this child. And she's just existing there as she's meant to be, without needing all of the care and feeding, if you will, right? Low maintenance.
So is that angel child sitting there next to you right now?
Not at this moment. No, of course I'm not referring to my children, Sean. I would never do that. But that is an analogy. It's really, you're right. Lithium is so finicky, and that's part of the reason that it catches fire. It's like the conditions are not extremely optimal, and our system is able to operate under conditions that lithium never could and will not perform well under for a much longer period of time.
Yeah. I think though, like with any kind of energy storage, gasoline, flywheels, when you're putting a bunch of energy in a small space, there always is some kind of danger of it releasing that energy all at once. So I think with capacitors, the problem that they had in the past is they can only put so many electrons to one spot before it shorts out. So I would imagine if you took your 8 kilowatt hour energy storage system, supercapacitor, whatever you want to call it, and you tried to put your 8 kilowatt hour module, and you tried to put 20 kilowatt hours in there, something not good would happen. Or I'm sure there would be some kind of safety mechanism that would just say,
please
no
don't.
more. Yeah, we're not going to allow any more.
That sounds reasonable. I haven't seen that test, but I do agree that there's only so much you should do to something before something bad might occur.
Yeah.
There was actually a heat test that was run because, again, I said the optimal range for full efficiency is up to 140 degrees Fahrenheit. And group decided to test it and just see how high could you go. And it was at about 300 degrees when it finally really had enough.
What happened then? That's the exciting part.
I think it kind of just, it stopped working altogether and it got a little, a little bit of combustion, but still no hazardous materials, no risk of, it's not going to actually explode. I've talked to some firefighters or former firefighters who are like, lithium fires are explosions that happen over and over. It's like plasma. And the amount of heat, like 2,000 degrees that it can get to is insane. So, and it's not just its own fire risk that it creates. It's what happens when you have an external fire source, like a wildfire. You look at something like that, that's a bad news story.
Probably it's still a lot better than gasoline fires.
Well, that's true. But we don't really want to settle for good enough. I think that, yes, lithium might be better than gasoline, but it's just been a good enough solution for a long time. And we don't want to stop there. It's time for something better. One example of that is we're air shippable. So because we don't have that heat risk, you can airship our modules. So especially the smaller units can be airshipped very easily. And so that just opens up, all kinds of doors for ways that people can operate more optimally. Where, military applications, going to staging containers in areas for later deployment. And if there's an emergency, there's all kinds of ways that you can use this that lithium hasn't worked well in, because most solutions don't hold energy without leakage for as long as we do, and aren't as safe. So it really is time for something else. And so, as you can tell, I'm excited about it, but not because it's who I'm working for. It's really because of what it is. Mm-hmm. And you mentioned cost, and we're not cost prohibitive. We're very, very reasonably priced, and we don't have production coming from China, so there aren't tariff issues, and our costs will be even more manageable as we get established manufacturing in the US.
We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSEAN, that's solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show. Well, this is pretty exciting, and I've heard that, the holy grail thing about supercapacitors for so long, and it sounds like you might have figured it out. Do you have other people that are doing something similar to you, or you're the only company out there?
There are other companies. Everyone who's poking at this wants to produce a competitor or, show us, hey, what about this company? They typically have issues like there are other graphene-based companies. There's one that's like in Europe and Germany, I believe. They can't do long duration like we can. And of course, it's one of our patents. And then there are others that have like nanograph is graphene and there's silicone in it, your favorite. But it actually, as last I checked, it has lithium in it as well. So, I have not seen any technology that has been able to do this. And there's a reason why I dropped everything and came to work here. Mm-hmm. And there's people knocking on the door all the time. They're like, hey, this sounds like the most amazing thing ever. And usually the reason people don't believe it is because it isn't everywhere. It isn't ubiquitous yet. But it's one of those situations where, like I mentioned, we're waiting on UL, but people are generally risk averse. And this is a big energy storage. Energy is a big deal, right? A lot of things depend on it working well. And so there's just that pace of adoption that has to happen. And it is about to be there. We're about to get there.
Yeah, it seems too good to be true. And so you said there's people knocking at your door. Okay, I'm knocking at your door. I'm building a solar training center right now, or I should say solar and storage training center. And I want to get some of your Mtel energy going on. I'd like to get an M wall. How can we do that?
You can get it. We have a distribution channel for, smaller orders, but we're doing, volume as well. So of course you can get one. You can get one of the first ones that are under the new release. We're doing the box build in California. So are you in California?
Yeah. Bay Area.
Okay. Yeah. Mm-hmm. Yeah. So it's Northern California. So it'll be available very soon, probably close to the time this comes out. So you can get one of those. We have people test our micro modules all the time. So they're rack-based modules that are very flexible for backup, they were used for telecom originally. And those are now 8 kilowatt hours. And we've had some third-party tests run on those, and they actually say they love them. Our MWall works well with solar. Right now, we're working in collaboration with Solar, to have an energy storage and inverter marriage. And Solar said they absolutely love it. So I don't know when anybody loves energy storage, but apparently it's lovable. So that's great news for me.
So if it works with Solar, I'm guessing that it's somewhere around like 48, 50 volts then?
It's 48. Mm-hmm.
Yeah. Okay, cool.
That's right. And the larger systems can be combined in series, so like up to 1500 volts DC in series. But, the smaller units can be combined in parallel, so we don't increase the voltage.
Okay, so I'd like to get some of these so I can discharge to 0% every day. I just want to do that. Sounds like
That's
a lot
right.
of fun. Yeah.
Yeah. Nerd out with it.
Yeah, yeah, yeah. And you said like it goes up to 1500 volts. And so that would match, the highest voltage that you could have on a solar array for utility scale and all that kind of stuff. Then you said that you're putting in some big system for the utility up in Ukiah. And I've stayed at Ukiah too. A long time ago, I took some solar classes at the Solar Living Institute, which is closed down, and they might try to bring it back or something. But it's up there in Hopland, right close to Ukiah. So if you go to Hopland, there's a good chance you're staying at a hotel in Ukiah. And I believe too that Ukiah has its own utility. And it's kind of, like an alternative type of town up there in Mendocino County. So is that who you're working with? Is the utility up there?
No, actually, this is for a tribe. So the tribe is pretty small, and they wanted to have power for several days in case of an outage. So they have complete energy sovereignty. Once the system is up, they'll be off the grid and they'll have 5 days of backup power.
Very cool. All right. And is this one already installed up there?
It's not installed yet. They're getting ready to, it's in production and then it will ship out. And so as soon as it's installed, you can go visit it.
Okay. Yeah. I want to go visit it and just kind of touch it and see,
see it go to zero.
See it go to zero and then like have a relationship with it. Get into technology that way.
That's right. Yes. I think it would be a great thing for you to go check it out right in your backyard.
So where is Mtel USA headquarters?
We are, like I said, we're lean right now. So we don't have much of a physical headquarters. We're based out of North Carolina and near Raleigh. That's kind of our primary presence. I'm in Northern Virginia, and then the rest of us are kind of spread out around, mostly on the East Coast.
Good. Yeah, that sounds very solid state of you to be spread out like that.
Yeah, and we are looking at, like I said, bringing the larger systems for manufacturing here very soon. And so then we'll actually be more established. People can come visit, see what we're doing, and all of those good things.
Well, great. So maybe we can touch base again in a year and do another podcast and see where you're at. That might be kind of cool.
Yeah, that would be great.
And then do you have a presence at any of the solar conferences, solar and storage conferences, I should say?
We're gearing up for RE Plus. So are you going to be at RE Plus in September?
For sure. Yep.
Yeah.
So maybe I'll see you there in person or something like that.
Of course. Yeah.
Are you going to have a booth?
Yeah, we have a big booth in the energy storage section. So back over in Caesars. So we'll touch base.
I'll keep a lookout and I'll be doing podcasting from there. And also I will be presenting, I'll have a solar class and a storage class on the Monday before, the big conference happens. So, yeah.
Okay. That would be great. Yeah.
With my friend Bill Brookes.
Nice.
Well, thanks, Stephanie Choi Brookes of Mtel Energy USA for being on Sean White's Solar and Energy Storage podcast. To find out more about solar, about storage, go to SolarSEAN.com and get yourself NABCEP certified. That is a great way to have job security, is getting that NABCEP certification and investing in your brain cells, which are solid state, aren't they, Stephanie? Are brain cells solid state?
I think so.
Something like that, yeah. Okay, well, have a great day.
Thank you, Sean. I appreciate your time. It was great being here.